All right, so yesterday we talked about, and the day before, we talked about permutations, which is how to find out how many combinations, sorry, not the word combinations, bad word to use today, how many different ways things can be put in order. Today we're going to learn about combinations. I don't want you to confuse those two, okay? And this is, again, when order matters. So how many different ways can I rearrange those letters? How many letters are in the word April? 5. So the way we would find that is what? 5 factorial, which is 5 times 4 times 3 times 2 times 1, right? 5 times 4 times 3 times 2 times 1, which is 20 times 6, or 120. That's the first part.
Is there a button that, like...
The exclamation mark. And then it says, and then 3 letters of the word. So now we're pulling out just the 3 letters, which changes this to a permutation with a certain amount at a time, right? Which is that P, this would be 5, this would be 3. And we will write out, because I warned you yesterday, if you don't do this, you don't get full credit, right? We'll write out that this means 5 factorial over 5 minus 3 factorial, or 5 factorial over 2 factorial. Without a calculator, I can expand it. 5 times 4 times 3 times 2 factorial over 2 factorial. These would cancel, and it'd be 20 times 3, or 60. And then yesterday we talked about how to find that in the calculator. So you can do it either way, but you have to give me at least this step, okay? All right, number 2 is basically cutting straight to the permutation part. So it's telling you to evaluate a permutation of 15 elements, 9 at a time.
Do we have to also write it out?
Yes. So either way, like, so in this example you mean? So like this one, it would do the same thing. I would do 15, I would do 15 factorial over 15 minus 9 factorial, which is 15 factorial over 6 factorial. And then again, you could write that all the way out, or we talked about yesterday how to find it in the calculator. 15, 6, and this would be 3603,600. So 3,603,600. Alexis.
Which number in the calculator do you like first?
The N, the one on the left. You put it in the exact order that this is. So if you have an NPR button, then I would do 15 NPR 9. Oh, that's because I wrote 15 P6. So let me correct mine. 9, a much bigger number. 1816. Oops. 214400. Try that again. So 1,816,214,400. Is that what you got? Yeah, okay. And then the last one, evaluate P when N is 2, or sorry, when N is 9. And R is 2, and this is just 72. So I'd get 9 factorial over 9 minus 2 factorial, which is 72. Questions on any of that? Okay. Number 4 says, there are 8 students running for class president. The order of student speeches is chosen at random. Find the probability that you are chosen first to give your speech and your friend is chosen second. So how many would just be the order overall? Like if I just wanted to figure out what goes in the bottom, what are the different possibilities? What goes there? 8 factorial, okay? But in the top we're saying how many slots are already filled? 2, which means there are 6 left. Good. So 6 factorial over 8 times 7 times 6 factorial, and I get 1 over 56. 7.
Couldn't you just do 1 over 8 times 1 over 7?
Yes, and we're going to talk about, I mean, you could do that now, it's fine, but I didn't want to confuse you because we're going to talk about independent and dependent probabilities, which is in the next couple of sections. So I'm keeping it in terms of permutations here just so that we're consistent, but yes, and I think that's easier. You'll get there. Okay, so homework from 30 says the judges in an art contest award prizes for first, second, and third places out of 11 entries. which expression gives the number of ways the judge can award first, second, and third places? So, what is my overall? 11. Okay, and then if I take away, so don't look at this as though it's an odd because it's a fraction, right? It's just that it's your permutation not already solved. So you're still taking it how many at a time? How many are you trying to figure out? First, second, and third, which would three places. So it'd be 11 factorial over 11 minus 8. Nope, 11 minus 3 factorial, which is 11 factorial over 8 factorial. So this is different, like if you're thinking like it's like the one at the end. The one at the end says what's the odds you're going to be in a certain order if somebody is in a fixed place and somebody's in a fixed place. That's when you take it away. This is different. This is saying like, how do you find if you're taking 3 out of those 11? Alejandro? 33. Using combinations. So there's 2 different types of probabilities so far that we're talking about, and that is permutations and combinations, okay? So permutations is if the order matters. How many different ways can I arrange something? How many different ways can I put something in order? How many different ways can the, people participating in a race finish? How many different ways can I take people in seats and rearrange them? All of that is permutations where the order matters, okay? Today, combinations. So combinations is selection of objects in which order is not important. So it's used when drawing for identical prizes. And order does not matter. So the difference between a permutation and a combination, again, is order does not matter. If I had, let's say I had like the colors of the rainbow, so, which is 1, 2, 3, 4, 5, 6, 7 different colors, right? If I said, in which way can I arrange the letters of this? That's permutation. Okay, if I'm saying which way can I arrange if I take 2 out of them, any 2 colors, then I can say that I can pull a red and a yellow, and that's one way, but I can also pull a yellow and a red, and that's a different way to arrange the colors. You with me? Those are permutations. Combinations are just red and yellow. Whether it's red and then yellow second or yellow then red second, that's the same combination. It's a different permutation, but it's the same combination. So there are going to be less combinations than there are permutations. Okay, does that make sense? Because in a permutation, if I were to roll a die and I pick numbers 1 and 2 is different than 2 and 1, but in a combination, they're the same. Order does not matter. Does that make sense? Okay, so count the combinations of 2 letters from A, B, C, and D. So see if you can list them. All right, so if we were to list it, I could say A can go with B, A can go with C, A can go with D. Did everybody get those? Yep, then I can say B can go with C and B can go with D. B has already gone with A, so I don't use that one. And then I can say C can go with D, and C has already been paired with A and B. And then D has been paired with A, B, and C. So how many are there? 6. Good. So permutations, there's a little formula that you can use to get combinations. The number of combinations of n objects taken are at a time. So the n and the r stand for the same thing. N is how many objects there are. R is how many you're taking at a time. And it's n factorial, which hopefully looks familiar, over n minus r factorial, still the same. What's different between permutation and combinations is you multiply the combination's denominator by r factorial. So you add that in. So n factorial over n minus r factorial times r factorial. And because we put another number in the bottom there, it makes it a smaller count, which should make sense. There's going to be less combinations than there are permutations. So you order a sandwich at a restaurant. You can choose 3 side dishes from a list of 8. How many combinations of side dishes are possible? So what's my n? 8. And what's my r? 3. Good. So 8 factorial over 8 minus 3 factorial times 3 factorial. So this time when I'm simplifying, it's going to look a little different. Okay, so this becomes 8 factorial over 5 factorial times 3 factorial. Without a calculator, I would bring the 8 down to the 5. So 8 times 7 times 6 times 5 factorial. And then I actually like to put the 5 factorial right underneath it, so I know to cancel it out. And then I will have to expand out the 3. 3 times 2 times 1. So this cancels out. And then this also, 2 goes into 6 3 times, and 3 goes into 3 once. So now I've got 8 times 7 times 5. Or this is 40. Yeah, it's just simplifying. So I'm saying without a calculator, I would do it differently. So this is 280. Which is, yeah, you're gonna have to.
That looks
I just simplified it. I just took the bigger one, went down to the next biggest factorial on this bottom, and then cancel those out. And then I simplified 8 times 7 times 6 times 5 with 3 times 2 times 1.
But didn't you cancel out the 5 with the 5 factorial?
Yeah, that's why
Oh, sorry. I did, I canceled out the 5. This is gone. So it's this left, okay, which is just 8 times 7.
Oh, because the bottom equals 6.
Correct. Yep. Good?
That makes sense. Wait, the answer's
56. You want me to do that again?
no, I got it.
So go back to your calculators with your handy dandy buttons that have C and R. You see, right where that PNR is also, or NPR is also NCR. Okay, the number is 8, the R is 3, hit enter, and you get 56. But again, so I'm super clear, I still need this step. I need you to go from here to simplifying it there, and then you can use your calculator. But you gotta at least show me you know the formula, okay? Because this can be done without a calculator. Alexis.
What's the name of it?
It's combination. So it should be, it should be the same button. Oh, yours is, it's probability, PRV, right? It's still PRV. And then go over till you find the one. All right, a yearbook editor has selected 14 photos, including one of you and one of your friend, to use in a collage for the yearbook. The photos are placed at random. There's a room for 2 photos at the top of the page. What's the probability that your photo and your friend's photo are the 2 placed at the top of the page? So decipher this for me. What's what?
14.
N is 14. And R is 2. So 14 factorial over 14 minus 2 factorial times 2 factorial. Really not that bad, right? Because I can break 14 down. 12. And this is 2 times 1. So those are gone. 7 times 13. And 91. So the probability, this is the probability that you and your friend's photo, this is my overall number of combinations. And you are one of those combinations. You get that? So if I take from those 14 pictures any pair of 2, one of those pairs is you and your friend. You get it? Yes? If it was a permutation, how many of those pairs would have been you and your friend? 2. One where you're first and your friend is second, and the other one where your friend is first and you are second. Does that make sense? Yes? Okay, questions? Did I record that? So the difference between this and combination, I don't know if I hit record. So again, if this was a combination, is you and your friend in either order. So it's one of these different combinations is that. In permutations, you'd have you first and your friend first. I mean, you first or your friend second, and your friend first and you second. So it would be 2 out of those. Okay. All right, example 4. Your teacher randomly chooses 2 out of 18 students to give an impromptu debate on freedom of the press in the high school newspapers. What's the probability that your teacher chooses you and your best friend? Okay. All right, 2 out of 18 students is your combination, right? So if I was to write this in the terms of C, it would be C with 18 on the left and 2 on the right. So 18 factorial over 18 minus 2 factorial times 2 factorial, which is what? Just give it to me. I didn't even type it in. 153. Okay, that's how many total combinations that there would be, and how many of them are a result of you and your best friend? 1 out of those 153 options. Well, it depends on what the scenario is that they give you, but yeah, I mean, it could be how many of them are between you and your 2 best friends. Now you're getting 2 pairs out of it. Does that make sense? Okay. Does that make sense, Nick? You're good?
Yeah,
Okay. All right, easiest part. It gives it to you straight up. So C, 10 on the left, 8 on the right, means that that the 10 is the N, the 8 is the R, and 24 on the left, 10 on the right, means that the 24 is the N and the 10 is the R. And again, you need to show this step, 10 factorial over 10 minus 8 factorial times 8 factorial. 10 factorial over 2 factorial times 8 factorial. Okay, so the first one you should have gotten 45. Second one, 1,961,256. Raise your hand if you got them both right. All right, good. Questions on permutations or combinations. Hardest part is figuring out the difference between the 2 of them. Remember, permutations, the order matters. Combinations, it does not. You are going to get more permutations out of something than you're going to get combinations. And look for the word probability. Probability means take the chances that it's whatever you're going to want out of that situation over the total amount of different combinations or permutations depending on what you're looking for. Okay.